9, numbers 1, 3, 5 through 8, 9 through 25, every other odd, and 27 through 33, odd. Please go ahead and get out your homework, your books, notebooks, pens, pencils, and calculators, and let's get started. Okay, let's take a look at number 1. Now for numbers 1 and 3, the directions ask you to do two things. If you'll look at your book, you'll see in the directions, letter A says, is the change in the inputs the same? Letter B says, is the change in the outputs the same? And then C, is the function linear? Well, we really didn't go over this in your notes, but I kind of want to give you something to think about on your own. And whenever you have a linear equation and you put in values for x and you get out y values, if this side over here is increasing with the same value and this side is also, then you always have a linear equation. So let's see. We're going from -3 to -2 to -1, 0, 1, 2, 3. So every single one of these, we're adding 1. Over here, we're adding 3 over and over and over. So the answer to question A, is the change in the inputs the same? The answer is yes. And the question to letter B, if you'll look in the directions, you'll see the letter B says, is the change in the outputs the same? Well, the answer is yes. I mean, the change here is a +1 over and over and over. The change here is a +3 over and over and over. So these changes here are the same. That's why I said yes here. These changes here are the same. That's why I said yes here. And whenever you have two yeses right here, then the answer to C will be yes. You always have a linear relationship or a linear function when these two columns, when their change is the same for each column. Okay, let's go ahead. Let me grab a drink here and let's try number 3. Okay, number 3. Are the x values or your inputs, is their change the same? Will we add 15, add 15, add 15, add 15? Yes, we're adding 15 every single time. Now over here though, let's take a look here. Here it's going to be, let's see, we added 2.5, and then if we add 2.5, we're good. And then if we add 2.5, we should get 9.7. So it starts off looking really good. It looks like we're adding 2.5 over and over. But when you go from 5.7, or no, excuse me, when you go from 8.2 to 9.3, you're not adding 2.5. And look at this. When you go from 9.3 to 11.3, you're not adding 2.5. So the answer to question B, are all of my outputs changing? Do they have the same change? The answer is no. So if both of these are not yes, then you do not have a linear function. You do not. All right, let's continue on. Let me get a drink here, and we'll continue on to 5 through 8. Now, 5 through 8, the directions simply say find the slope. Now, remember, whenever you're given a graphed line, you use the formula rise over run. And you want to pick 2 points that have whole numbers. So here's a point here, and here's a point here. And then remember, you draw a triangle. Now you can go to the right and then down. That's acceptable. Or you could go, if you wanted to, down and then to the right. And that's acceptable too. It really doesn't matter. I'm going to go this way and then this way. Okay? Now, first of all, we find the rise. That's how high this line is right here. Okay? So let's put our pin here and let's count up. 1, 2, 3. Notice how I don't count when I put my pin on the point. I don't put my pin here and say 1. I don't count until I move to the first space or the first increment. So 1, 2, 3. So my rise is 3, and my run, now the run is the distance or the length of this line right here, my horizontal line. Now notice when I put my pin here, I don't count. I count when I move to the first space. So I put my pin here and I go 1, 2, 3, 4, 5. So my run is 5. So it looks like your slope is 3/5. But remember, whenever a line is sloping downward from left to right, your slope is negative. So your final slope of this line is negative 3/5. All right, let's take a look at number 6. For number 6, there's really not a lot of work. Anytime you have a vertical line, the slope is undefined or no solution, however you want to say it. So whenever a line is perfectly vertical, left and right, then the answer to the slope is undefined. There is no slope. Number 7, there's really no work to show. Whenever you have a horizontal line, the slope is always 0. Anytime you have a perfectly horizontal line, the slope is always 0. And that makes sense. It's flat. There's no rise at all. There's no steepness. There's no steepness to the line. And so your slope is 0. All right, moving on to number 8. Now, remember, whenever you're trying to find the slope of a graphed line, you use the formula rise over run. So here we go. Here's one ordered pair that has whole numbers. Here's another ordered pair. Let's draw our triangle going straight over and then straight down. Always draw a right triangle. And now let's find the rise. Let's count up. So you put your pencil here, and you don't count until you make your first movement. So I put my pencil here. 1, 2, 3, 4, 5. So my rise is 5. Now let's find the run. The run is the length of this line right here. So I put my pencil right here, and I don't count until I make my first movement. So 1, 2, 3, 4, 5, 6, 7, 8. So the run is 8. So the slope is 5/8. Now, would it be positive or would it be negative? Well, think about that. I mean, if you go to the left of the line and then work to the right, so read the line from left to right, it's going upward. From left to right, it's going upward. So your slope would be positive, okay? All right, let me grab a drink and we'll continue on here to numbers 9 through 25, every other odd. Now, whenever you're given 2 points and not the graph, and you're asked to find the slope of the line that passes through those 2 points, the formula you're always going to use is y minus y over x minus x. So with that in mind, here we go. By the way, it doesn't matter which y value you put in first. If you put this y value in first, then for your first x, you've got to put this value. If you choose for your first y value to put this y value, then for your first x value, you must put this x value, okay? So it really doesn't matter. It's up to you. I just usually go in order. So here's my x and y. Here's my x and y. So my first y value is 4, and then minus my second y value is 2. 4 minus 2. My first x value is 9, and my second x value is -1, so minus a -1. Now you can use a calculator or do it in your head. 4 minus 2 is 2. 9 minus a -1 is 10. So the slope of this line is 1/5. All right, number 13. Y minus y over x minus x. Well, here's your first y and here's your second y. So -0.1 minus -0.4 all over x minus x. Here's your first x, here's your second x. So 0.7 minus -0.3. All right, so here we go. Let's see what we get. Up here in the top, if you have a -0.1 minus a -0.4, you will get out a 0.3. And 7 minus a -0.3 is actually going to give you 1. So we have 0.3 over 1. Now, we don't want a decimal within the fraction, so we're going to move this decimal up top one place so it's gone. But if you move the decimal in the numerator one place, you must also move this decimal down here one place, okay? So if you move the decimal up top one place, that gives you 3. If you move the decimal down here one place, that gives you 10. So the slope of this line is 3/10 or 0.3. Moving on to number 17. Okay, y minus y. Here's your first y. Here's your second y. So we're going to have negative 3/5 minus 3/5 all over. Here's your first x. Here's your second x. So 1/2 minus a negative 1/2. Now, you can use your calculator or do it in your head. It's up to you. A negative 3/5 minus a negative 3/5 is a negative 6/5. And a negative 1/2 minus a negative 1/2 is a positive 1/4. So now look what you have. You have negative 6/5, the top here, divided by the denominator, so which is 1/4. So divided by 1/4. So negative 6/5 divided by 1/4. Now remember, whenever you're dividing fractions, you change it to multiplication and you flip the fraction. So your 1 would be in the denominator and your 4 right here would be in the numerator. So there we go. Now let's go ahead and multiply, and you would end up with 24 negative. A negative times a positive is negative. 6 times 4 is 24, and 5 times 1 is 5. So the slope for number 17 would be, and it looks like I might have made a mistake, which happens sometimes. Hold on one second here. Okay guys, I'm back, and you know how mathematicians always make those little mistakes, and I apologize, but I mean, it is what it is. We all make mistakes. So, and I'm not sure where I got a 1/4 from. That's really funny, but a 1/2 minus a negative 1/2 is 1. So you really have negative 6/5 over 1, which is of course just simply a negative 6/5. So I apologize for confusing you, and hope that makes a little better sense. And let's continue on to number 21. All right, here we go. Hopefully I will be a little more careful with my mistakes. Okay, let's find the slope of the line that passes through these two ordered pairs. So first of all, we're going to do y minus y. So negative 3 minus 2. Negative 3 minus 2. And then in the denominator, we're going to put x minus x, which is pi over pi. Now, negative 3 minus 2 is a negative 5, but anything minus itself is 0. Pi minus pi is 0. So we're going to stop right there. Anytime you have 0 in the denominator, that means you have undefined or no solution. So the slope of the line that passes through these 2 points is undefined. Now think about that. We know right away then that the line that passes through these 2 points is a what type of line? Remember, what type of line always has a slope that's undefined? A vertical line. So we know without even graphing these 2 points that the line that passes through these 2 points has to be vertical, okay? Because a vertical line always has a slope of undefined. And because your denominator had a 0, then your slope is undefined. All right, let's take a look now at number 25. Now, I understand, let me get a drink here. I know this notation looks a little weird, but I actually chose this problem so you would learn to work with situations like this. F of 1/5 equals 1/2 just simply means we put 1/5 in and we got out 1/2. It's an ordered pair. F of negative 1 equals negative 11/2. That means we put in negative 1 and we got out negative 11/2. So it's just an ordered pair written in functional notation. So now that we've solved that, here we go. Let's find the slope of the line that passes through these 2 points. Y minus y, well, your first y is 1/2 and your second y is a negative 11/2. X minus x, your first x is 1/5. And your next x is a negative 1, so minus a negative 1. So here we go. 1/2 minus a negative 11/2 would be 12 over 2 all over. And then 1/5 minus a negative 1 is plus 1. That would be 1 1/5 or 6/5. Now, the numerator can be reduced. 12 over 2 is 6. So we have 6 over 6 fifths, or in other words, 6 over 1, because 6 right here is the same thing as 6 over 1, divided by the bottom fraction, which is 6 fifths. Now, when you're dividing fractions, we make this multiplication and we flip the second fraction. So your 6 should be in the denominator and your 5 should be up top. And now that we've done that, we're ready to multiply these two fractions together. Your 6's would cancel, and 1 times 5 is 5, and 1 times 1 is 1, so 5 over 1 is 5. So the slope of the line that passes through these two ordered pairs right here is 5. Let me get a drink of water here, and we'll continue on. Let's take a look now at 27 through 33, the odd. Graph and then find the slope. Okay, here we go. We know how to do this very quickly. I'm going to make a table of values. And I'm going to put, in fact, we just actually put in 3 numbers. And whatever, I can put anything in for x that I want. I'm going to use 0, 2, and 4, and I'll tell you why. I know if I put in a 2 and a 4, I will not get out a fraction. Now, if you want to use 0, 1, and 2 like we've done a lot, that's totally fine. Nothing wrong with that. You'll still get the right answer, okay? But I'm going to use 0, 2, and 4. If you put a 0 in for x, 1/2 times 0, 0 plus 3 is 3. If you put a 2 in for x, negative 1/2 times 2 is negative 1, and negative 1 plus 3 is 2. If you put a 4 in for x, negative 1/2 times 4 is negative 2, and negative 2 plus 3 is 1. So you have your 3 ordered pairs, 0, 3, 2, 2, and 4, negative 1. So I'm not going to try to be super neat. I'm going to draw a very quick coordinate plane. My first ordered pair is 0, 3, and that would be right here. My second ordered pair is 2, 2, that would be right here. And my next ordered pair would be 4, 1, and that would be right here. Okay, so there is the line that I'm going to graph. And I would draw the line like this. I'm just going to kind of sketch it here. I'm not going to try to draw it perfectly, but there we go. Now let's quickly find the slope like the directions say. You could use these 2 points here, or you could use these 2 points here, or you could use the 2 furthest points. That's what I'm going to do. So a line straight over and a line straight down. Okay, let's find the rise. The rise starts here and goes to here. So we count up. Now here's where your pin is. We count up 1 and then 2, because this point is even with this tick mark right here. So I went up 1, 2. Alright, so here we go. 1, 2. So the rise is 2. Now let's find the run, the length of this line right here. Alright, so we start here. We don't count until we make our first movement. So 1, 2, 3, 4. Okay, 1, 2, 3, 4. So my run would be 4. So rise over run is 2/4. If we reduce that, we get 1/2. And notice how the line is sloping downward from left to right. So the slope of the line is negative 1/2. Negative 1/2. Okay, let's continue on to 29. And let's go ahead and do our, this would be a good problem here to use the double intercept method. That's what I'm going to do. I'm going to put a 0 in for y. And if you do that correctly and then solve for x, you will get x equals 2. And now I'm going to put a 0 in for x to find the y-intercept. Okay? If you solve this correctly for y, you will get negative 3. Alright? So, what we have is, let's see if this is right real quick, negative 6 and let's see, -3. Okay, just checking the work there. Everything looks fine, so let's go ahead and get our table of values drawn here. We have an x-intercept of 2. Here's my x-axis. And I have a y-intercept of -3. Here's my y-axis. So I go to the x-axis at +2, put a point there. I go to the y-axis at -3, put a point there, and then we sketch our line. And there's our line. There we go. I mean, that's really pretty simple, students. Okay, now let's find the slope. So we're going to draw a right triangle connecting these 2 points. Now, let's find the rise. So we start right here, and we don't count until we make our first movement. So I go up 1, 2, 3. So the rise is 3. Now let's count the run. So I start here, and I go 1, 2. 1, 2. So the run is 2. Notice the line is going upward from left to right, so it's a positive slope. And let's go back a page real quick. Over here, we did call it a -1/2, so good, just making sure. The line is sloping upward from left to right, so it's positive, and the rise is 3 and the run is 2. So the slope would be a +3/2, a +3/2, okay? Let's see what else we have here. Number 31. Now, number 31, again, looks like a problem which I could use the double intercept method. If I put a 0 in for x, and then solve for y correctly, I will get y equals 5. So the y-intercept is 5. If I then put a 0 in for y and solved correctly, I would get x equals 2. And so now that I know those 2 intercepts, I can very quickly go to the x-axis and put a point at 2, and go to the y-axis and put a point at 5, and then draw my line. All right, and let's see if we can do that. There we go. All right, not perfect, but good enough. Now, let's go ahead and draw a right triangle, and let's find the slope. Let's find the rise first of all. We're going to start here, and we'll go 1, 2, 3, 4, 5. So my rise is 5. Now let's find the run. I start here. I don't count until I make my first movement. So 1, 2. 1, 2. So my run is 2. So it looks like my slope is 5/2, but notice the line is sloping downward from left to right, so the slope would be a -5/2. And finally, the last problem, number 33. Okay, let's go ahead and graph this linear equation. This is my y-axis. This is my x-axis. And remember what I've taught you. Whenever you have just a y in your equation and no x, your line is going to be horizontal. And whenever you have just an x value in your equation, just an x with no y, then you're going to have a vertical line. Well, this is y equals 2/3, so I know that I'm going to have a horizontal line, and I know I go to -2/3 on the y-axis, which is about right here. And then from there, I go ahead and draw my line. So my line would look something like this. There we go. And of course we know, hopefully by now, that whenever a line is perfectly horizontal, the slope is 0. Okay? If the line's perfectly vertical, the slope is undefined. And that's so easy to remember because a flat line is flat, it has no slope. And a vertical line going up and down can't have any slope, because how would you define the steepness of that line? You would have to simply say that it's a vertical line. Okay, so the slope of a horizontal line is always 0, so there's the slope. I hope this homework help video has been a help to you. Call or email if you have any questions.